Yes, guys. Okay, great. Okay, so what we want to do is we want to basically understand the performance optimization, optimized code. Okay, so but how do we optimize the code, Python code? Basically, that's what we are going to learn today. Yes. So I will start with some question, right? So there are two terminology that the two terms basically that people will generally ask in the product-based companies, right? So it generally in the product-based company because majority what you can do it basically in the product-based companies they will basically ask you two things. Whenever you write a code, they will ask you tell me the time complexity and space complexity. Yeah. So TC and space complexity SC. Okay. So this is called time complexity. Yes. And space complexity, guys. There are two questions they will ask you whenever you go for some really good companies. Yes, they will ask you whatever code you are writing, they will ask you, tell me what is the complexity. And if higher time complexity is there, then they will ask you to say, okay, can you optimize it or can you actually make it less time complexity, less or space complexity. So this is the origin. That's where I'm just putting the focus here first. Okay. So then we will build the story actually around it. Now, let us try to understand a little bit about one question, very basic question, right? So we all know that we can write a code in a different way. For example, let me just start with this and then I will talk about it. So I can write my code in algorithm. Let's say I'm writing algo 1 and algo 2, right? When I say algo 1, algo 2, different way of writing the same code. Yes. So if I say that, okay, I need to write one code which will actually just get me the square root. Yes. So algo 1 says something like this. Let us say I'll write it def and get square, not square root, let's say get square, square, that's it, okay? And I will just pass here, let us say one number here, perfect. And then I can say here, return number into number. Make sense? This will also give me like whatever number I'm passing, this will also give me same thing, isn't it? It will give me the square root. So if I just actually call it, let us say get square, and I say here, let's say 10, fine. Whatever, let's say 10. If I say 10 here, what it is going to give me? The answer is going to be 10 square, which is 100. Perfect. The same code, can I write in this way as well? Let me write it. I will say get, and I will write something get square using loop, something like this. And I will pass here number again here, same thing. Now, this time I'm writing in little different way. I'm going to use a for loop here. Okay, this is another way. Let's say I'm going to use for loop and I will say, okay, something like this for in range number. Yes, so it will go up to that number and maybe I will just say here, maybe answer equal to 0. I'll start with 0. And here, what I'm going to say, I'm going to say answer equal to answer plus number. Yes. And finally, after this for loop is completed, I will just say return answer. And this will also get me the same thing, isn't it? Square using loop, something like this, guys. And then I will pass it 10 here as well. And this is also going to give me the same thing. Yes, this is also going to get me 100. Why it is giving me 100? You know that, right? So how the for loop will work? Every time it will just add up that number. So every time it will get that number. Sorry, one second, one second. So what it is doing is it basically going to start. It is going to run for how many times? How many time number is there? So it is something like that 0 to number minus 1, right? So how many times it is going? So let me just dry run a little bit so then you understand it. Here, so it is clear, right? I will pass this number and this is just saying 10 into 10, isn't it? So this is 100. This is little tricky. So let me explain you. What will happen is I will just come here. Answer initially will be 0. Yes. And then first iteration will it. I'll go on. Why? This one, this is just doing one single operation, right? Here it is going to iterate it for 10 different times, right? It is going to run it for 10 times. Obviously, there will be some time. Here, it is just going to run only one time. Okay. Now the thing is, how do I compare whether algo 1 is better or algo 2? In this case, it is very simple, right? But in reality, if you see, the programs are like, 1,000 lines, 2,000 lines, something like that. Such a big programs, we actually get it, right? So is it like only one way that we can actually keep analyzing where is for loop, where is how many times we are running? It is not possible for us to do in that way, right? That's why we want to understand one more thing, right? So I'll just take maybe Ajay and Amit. Fine, chalo. I'll take Ajay and Amit here. Let's say Ajay here and Amit is here. Perfect. Let us try to understand. what happens basically, same algo, algo, it is the same algo, perfect. Same way he has written, okay. But now let us say algo 1, perfect, same code it is running. Now, for example, algo 1 is, let us do one thing. In this case, though, you know, right? Okay, fine. So let us say that this algo 1, okay, here's code. First parameters, I'm just talking about it. First parameter, let's say Ajay's code is running on Windows XP, okay? Windows XP. And Amit's code is running on Mac, okay? Mac OS, right? Now tell me which one, algo, same algo, which one will be faster in this case? Keep chatting here. I will come to know. Yes. Which one will be like, I'm just getting a confidence. Yes. Which one will be better? Mac one, right? Obviously, because that is having the better processor, everything. Yes. So this one will be better. Same code. Yes. I'm talking about same code. Now, second parameter is, let us say, this code, let's say this code is actually taking 10 seconds and his code is taking 7 seconds. Perfect. Now, what will happen? Ajay is actually going to increase, write the code, same code into C++, and this guy is writing the code in Java. Okay. Now, what is happening is this one is actually coming down to, let's say, 5 seconds and his code is still 7 seconds. Perfect. Which one is better now? Which code is better? Obviously, this algo one, Ajay's code is better because it is taking less time because we are counting on time, right? So this is what language also makes sense which language you are, because C++ is very fast, right? Now, third one. Let us say Ajay is sitting on top of volcano, right? Top of volcano. So you know the system is going to heat up, right? And his time is still 5 seconds. And this guy, Amit, goes and he is sitting on the top of Everest. Okay. Yes, fine. Top of Everest, he goes and his time actually increased to 4 seconds. Now tell me which algo is better? Man, whose algo is better? Obviously Amit's, right? Because his algorithm is working fine because it's taking less time. Okay. What I want to tell you guys is that based on there are several factors, like how one algorithm, same code may be written, but there are several factors that are impacting the time of a particular what do you say, time of particular code, right? How much it will be faster, because it can be machine, it can be language, it can also be volcano. So this is very difficult for a person. Let's say Amit can write his code in one way and Ajay can write his own way, basically, right? Let's say algo 1 and algo 2 in that case also. Now you can actually just tell me, but the thing is, in reality, it's so complex, you cannot be able to tell me, right? Now, you even don't know basically whether this will take or not. You're just guessing it, right? Because it is like doing the iteration, but you don't really know whether it is really taking time or not, right? So what we generally do is we actually take some parameters that is like not affecting based on the language, platform and everything, because there should be a common way to compare how one algo is better than other algo. Okay? There should be one way, and that's where, based on the execution time, what we are actually counting it here, based on execution time, we are deciding which algo is better, right? Algo is better. Yes, correct. Execution time. But execution is based on certain external factors, isn't it? So this is not a right way to compare it. Okay. So then what should be the right way to compare it then? That's where we get something called the iteration. Yes, that is called iteration. Okay. So the best way to compare two algos is based on iteration. Iteration, when I say, it's like how much cycle we are actually doing it. Here, in this case, I told you your code is running for how many times? It is running like 10 times, isn't it? If you are putting 100 here, correct? 100 into 100. So it will be going to run 100 times, whereas here it is going to run only single time, right? So that's where the iteration, wherever iteration is involved, that's where we call it the time complexity. Time complexity means how much time, how much iteration it is taking. And that particular iteration is called the time complexity, guys. Okay. So number of iteration. Now tell me one more thing. Okay. Tell me one more thing here. I'm just going to write something here. Okay, so one sample code, I'm going to write it. So we know we have to actually compare the number of iteration rather than comparing the time basically, which time it is taking and all those things, right? So we have to basically comparing two different algorithm based on the number of iteration. One second, guys, just a second. So let us try to understand one more thing that I want to talk about it. Acha, tell me one thing. Acha, same code, yeah. Let's try to look at it. Let's kind of understand this code, same code. Acha, tell me one thing, everybody. So this is running for only one time for sure, right? Is it actually dependent on the number of input? Tell me. Is it dependent on this number? Let us say I'm putting 1000, 2000. Is this particular internal code is running for those many times, or it is going to be constant? Right? Constant, or you can say it is going to be dependent on this input. So this is, let's say, my input, right? Because we are passing some number, right? Let's say 10, 20, 30. So this is going to be constant. So wherever there is a constant time, because this is ultimately one statement that we are running, right? In computer science, everything is instructions. So every statement that we are writing is one instruction. For example, this is one instruction. And here, this is one instruction, but there are multiple times it is running. So that many times it is instructions basically. Just tell me, the number of execution of this particular code here, it is dependent on the number of the number that input that we are providing. Let's say number we are providing 10. Definitely, right? If I'm putting 100, then it will be adding 100 times basically. This for loop is going to run 100 times. So can I say that this particular algorithm that I'm going to write, it is dependent on the input basically. Yes? Dependent on input. So tell me, if I put n numbers, then it is going to run n numbers, which means n number of times it is running. That's where there is some concept called, like, see, we cannot simply calculate it, right? Like we cannot calculate like how many times it is doing and all those things. So what we do basically, there is some concept called big O notation, okay? Or we also call it asymptotic notation. Let me actually explain it and then I'll come back to this algorithm again. And then we will code it also. You will come to know actually everything about it. So now let us say there is something to compare, and that way is called asymptotic notation. Okay. That asymptotic one thing, let us understand the asymptotic notation. That's where we are in, right? So asymptotic notation, there were basically three ways to compare which algorithm is better, right? Or which code base is better, basically. The first one is basically called big O notation, okay? Big O notation. And second one is basically omega notation, okay? Omega notation. And this you will be seeing big O will be something like this, okay? And then you will be writing the time complexity here basically, okay? Time complexity will be written here. And omega notation, something will be represented something like this, like omega only. And here also you will be seeing the time complexity, whatever it is there, right? Now, the third one is basically called theta notation, okay? Theta notation. And we generally, this is the theta, no? We all know. So theta, generally in our programming language, we actually do not go for the omega and theta. Nobody will even ask you to do that, but you should just know that there are three ways how we can actually know that which algorithm is better basically. So now entire thing that we are going to do is actually based on the big O notation. We will understand what is big notation, how do we calculate big notation, and what we can big O, right? Big O basically. Everything about that we are going to talk about it. Yes, fine. So three ways to do this. Now I will also talk about it and I will show you like how the code is actually running and how it is going to help you and other stuff. But for now, let us try to go back again here. We are going to discuss everything on the big O notation, and in your coding round also people will be asking big O notation only. Okay, you have to tell big O notation. They will say time complexity means you should by default know. They're talking only big O notation. They're not interested to know anything else actually. Yes, fine. Now, when I say this is going to be taking a constant time, okay? So big O notation says that, okay, something is taking the constant time. We have to represent something that the time complexity. First, we are talking only time complexity. We will talk about space complexity later, but time complexity because how much time it is taking, like how much iteration basically, not time, but the iteration, how much it is taking, right? So this is actually constant, right? So I will say for constant order of 1, okay? Because this is actually constant time, right? It doesn't matter like I put 10,000 here at 20,000 number, it is going to run only once it is, right? So that's why it is actually constant time complexity. Now here, it is basically dependent on this number. So how many times it is there, that many times this particular statement is running. So that's why the complexity here is actually saying that order of n. Why order of n? Because this is that many times it is doing. N means the input basically. So it is basically the input is n and that many times it is the complexity. So what it means is basically that it is going to be very fast and it is going to be actually slower. Okay. So what we want to do here is we want to understand a little bit more about it. And what I will do is I will actually write some program in PyCharm, and I will try and run it and show you basically how it is going to impact order of one and order of n. Now, you might just say that, okay, we have to always prefer to write the code base in this way because this is going to be taking constant time irrespective of my input. It is actually increasing, the time will be increasing based on my input, and that's what I'm going to write some code here. Okay, so let me just write one Python file, and I will show you after running it also. I'll show you how does it work basically. Same thing, yes, fine. If I just say, I will say TC examples, fine. Time complexity example. This is one of the things I'm going to write. Okay, so let us do one thing. I will do one thing. I will write two functions. Okay, one is I will say square. Okay, let me write it quickly. Square using multiplication. Perfect. One second, guys. Two functions. I will say square because I'm going to teach you not theoretical. Just I want to show you so that you get everything, right? So that's the thing. Yeah. Square using multiplication. Okay. This is what I'm going to do. And here I'm going to pass, let's say, number. And for number, I'm just saying n actually. Yes, any number that I'm going to say. And I'm going to say return here n into n. Agree? This is what is my first function. Perfect. Let me write the second function also, and then I will call both of the function, and then you will come to know, right? Second function, I'm going to say using for loop. Yes, using for loop. And I hope you all know that how to do. Here, I'm going to say here, let us say answer equal to 0. And I'm going to say for, you can write anything, but I'll use, because just I want to run it, no? So maybe I can say I, it's fine. Doesn't matter. I'm not going to use I anyways, right? So I'm just doing it for iterating it, no? So I will say range here. And I will say n here. Yes, I agree. Now I'm saying n answer equal to answer plus n. Okay. Every time I'm going to just add this particular number all the time. Yes. Now after once this is over, I'm going to return it. What I'm going to return? Answer, right? Second way of doing it. So two functions I have written, same thing that I explained you guys. Now what I'm going to say, I'm going to actually show you the time complexity, like how much time it is taking, the actual time that is taking. So how can I do that? I can actually call this function actually first. And when I call this function, let's say I'm actually putting some little big number. Yes, fine. And here I'm going to say result one. Perfect. This is result one. And I'm going to say, okay, before that, guys, I want to calculate the time also, no? So can I import time here? Okay, so because I want to use the start and end time actually. Okay, so I will be writing something like this. I will say start time. And can I say time dot time? Okay, so start time will be actually the moment it goes inside here, it will actually just capture the start time. Okay, now I will also say end time. So the moment it comes out of it, basically after once this actually function is completed, it will actually record the end time. Yes, can I say end time? End time, this is fine. Yes, good. So end time and start time, these two are going to be captured. And what I'm going to say here is, I'm going to say print here. Perfect. I'm going to say print here. And I'm going to say that total time, total execution time. Simple. I'm just going to write something. And here I'm going to just print this one. Yes. And can I do one thing? Can I actually use the f string? So you all know how to use the f string. Probably this is how we do that. And in this one, I'm just going to write a variable way, right? So if I say here end time minus start time, little thing, right? So I'm just subtracting how much time it was here and how much time. I'm just subtracting it. And then guys, what I have to do is I have to say one thing like this. 1 second. So once I'm done with this, I'm just going to write some decimal. So I want to put the 10 decimal point after that. So floating point that will be coming. So this is what it is going to give me total time that we actually got it. Let us see actually if okay, what I will do the same thing here as well. No. Okay, for the simplicity, let me say time one. That's why we can do it. So this is better. I will say time two actually for this one. Time two, and time two. Okay, but here I'm going to actually call the other function. What is that? Using this one. square for loop, right? So I'm just going to call this one actually here. Perfect. Everyone is okay with this code? This is going to tell me the total time for multiplication, I will say. Okay, multiplication way. Okay. I will say total execution using, what is that? Looping way. Perfect. Chalo. So this is going to print me the time actually, how much time we actually getting taking, right? Let me run it and show you what exactly we are getting. So we are here, and let us say we are here, and I'm going to say time complexity. Okay, perfect. Let us run and see that. Okay, we are getting some error. And what is that? Python. Okay, not Python. It's Python actually. Okay. All right. Let us run it. Guys, do you see that? There is no difference here, no? It is actually still showing me 0. But why it is showing 0? Because see, our processor, you know that how much, okay, I'll talk about one more thing. Why it is showing you 0? Okay, let me do one thing, acha. Let me increase this number to significant bigger number, okay? Can I just increase it to maybe, how much? Let's say 9 digit. It is 4 digit, no? 5, 6, 7, 8, 9 maybe. Yes. So I'm actually increasing it to 9 digit, okay? So 10 to the power 9. Fine. 10 to the power 9, like 1 gigahertz. Like that is what actually, what I will say 1 billion. Yes. This is the 1 billion time the code is going to be executed. Now, do you see that? What is happening? Do you see that multiplication is actually done so fast because it is order of n, right? And this probably will be taking many long time. I'm sure it will be taking very long time. I will kill it actually once. Okay. Let me actually try one smaller number. Okay. Let me just kill it first. I'll do one more time actually. And hopefully this should come faster. If it is not coming, then I have to kill it because this is really, really long number. Okay. Do you see that, guys? This is actually the order of n. And what I say n, this many times that for loop is running. Yes, starting from this many times the for loop is running. That's why it is showing you this is the 6th second. This is actually second. Whatever I converted, no, that is basically second. Okay. So this is actually taking the 6 second, basically 6.97 second. If I put one more number, it will be taking hours and hours actually. Okay. If I put one more number, maybe it will take, I don't know. Okay. I can't commit basically. So do you think the number, when it is increasing to a certain amount, the time it is taking is a hell lot of time basically. Yes. So that is what the magic about writing the optimized code. Okay. Think about it. If you have written this code and somebody is really putting a very, very big number, right? Because number you can put anything, no, any number you can put it. Your code is never going to be actually completed here. Okay, so I'll tell you one more thing here. So did you see this? What is happening here? Order of n. So you have to actually see that you are writing your code in a much optimized way. So here, if you're writing in the order one, it doesn't matter how big number you are putting, it will simply run only one time actually. Here it is running multiple times. Did you get some idea basically what I wanted to show you here? Quick thumbs up, guys. Now I will come about it basically. So this is actually always the time complexity is how many iterations we are doing it. That is the one. How many times iteration is simply meaning how many times your statement is running basically. Number of statements, how many times it is running. That is all about the iteration. Okay. Now I will talk about it. I will take another example. So in this case, maybe I'll take another example of something of I have written it here. Basically, I can just show you the code base. Actually, you can see it here. I've written something for the binary search. Do you see? This is binary search. Probably I will just not write it again. But this binary search, when I have written it, this two code base actually, only one code base here. Okay. Let me explain it a bit also here. So we have to really look for optimizing the code. So when you go for the interview, if you are giving you, so this is basically the logically, your code base should be optimized. We should always try to actually, so order of one is generally not possible, right? Because you have to write certain statements, number of statements and all. So order of one is generally not possible. Otherwise it is like super fast, super computer you will be actually creating, right? Only thing is we should be trying to actually optimize our code base. So I'll tell you what is the logically we should actually try to target. So I'll say show you the ascending order basically, right? So let's say order of one is better. Okay, so this is better. Now order of n will come. Okay, not n actually, order of log of n, log base n. Then you have something called order of n. Okay, because these are smaller. Yes. Now order of n square. Then order of what is that? N square. And then what else, guys? Let me just show you. Yes, I think order of n log n. Sorry, not n square. This will be So this is the people might ask you as well in interview. So log of 2n, actually base 2n. Yes, I'll talk about it little later. And then we have something called n square. Okay. And then we have something called n cube, order of n cube. Perfect. N cube. And this nobody will actually bear it. Actually, this kind of code, if you're writing, they will kill you, right? Now, order of, there is some programs where you cannot escape it, basically, something like 2 power n, 2 a power n. This is even the higher, basically. Yes. Now, the last one that you can see is order of n factorial. Got it? So this is basically the logically. So you should actually target your code should be somewhere lying up to here. Up to here, max to max, you should be optimizing your code here. Okay, you can write your code base into this way also, but these are not optimized code. And for very, very large input, your system will never come back. Maybe it might take a couple of years also to actually give you output actually. Okay. Okay, I will talk about one more thing. So do you guys know what is the processor of your machine? Something little off topic. Do you know what is the gigahertz of how many gigahertz your processor are actually? If you don't know, you can actually go and check the system and tell me. Yes. Now, guys, I'll talk about it. Generally, our processor machine, right? Processor actually tell you how much faster, like how many instructions processor tells how many instructions your CPU can run in a second. Perfect. This is what actually processor tells, right? For example, I say 1 gigahertz. Okay? 1 gigahertz simply means that it can actually run 1 billion instructions per second. Billion instructions per second. This is the simple meaning. Yes, you have, let's say, 2 gigahertz, it can actually run 2 billion instructions per second, not more than that. Okay, probably you all can actually check and see that how much actually gigahertz your processor is. Yes, and that many instructions you can run actually. Now think about it. Yes, this is 10 to the power 9 means 10 like 1 and 9 0 basically. So this is actually 1 billion. Okay, this is yes, 10 to the power 9 instructions per second. If you are getting some input where you need to run, let's say, more than 10 to the power 9 seconds, your computer this one will not actually work. Okay, it can work. Okay, it can work for some time. But tell me one second. Okay, fine. I'll tell you. Just give me a little mathematical calculation. This is going to be fun actually. For example, you have, let's say, 10 to the power 9 instructions in 1 second. Okay. Can you tell me how many, if I say 10 to the power 10 instructions, how much time it will take to execute 10 to the power 10 instructions? Okay, so this is going to be okay, 1 second, and it is going to be 10 seconds. Okay. Now 10 to the power 12, right? 10 to the power 12, if you want to do it, how much it is going to be? 10 to the power 12 divide by 10 to the power 9. So 10 to the power 3. How much it is? Basically, it is going to be 1. Is it 1000?
1000.
So this is how basically you calculate it. Okay. But what happens is if you have 1 gigahertz of the CPU, generally if you go and code on some platform like LeetCode and all, right? I don't know whether you explore it. There you will be getting some error that is called TLE. Okay. Why TLE? Because that only supports if your code can run. So whenever you go for the exam, right, like your coding round, they generally will ask you to go you hacker rank or hacker earth or whatever TLE. You will be getting actually some error called TLE, that is called time limit exceeded. Time limit exceeded. Okay, exceeded. And why this is coming? Because their processor, right, that platform processor is actually capable to process only 10 to the power 9 instructions per second. Okay. If your code is actually taking more than that, it is taking more than 1 second, then it will be getting TLE actually. And that's how your code will not be able to execute. Yes. So that's what I wanted to talk about it. All these examples actually I wanted to talk. Like if it is taking more than 1 second, then you will not be able to execute it. That's why you think about it. Now, if you have this many big number, 10 to the power 9, you can only afford order of n. Actually, can you afford order of n square? So let's say there are 10 to the power 9 instructions per second. Okay, 10 to the power 6 instructions. Yes. So what you have to do, you have to solve your problem in order of n only. Okay. You cannot afford to solve it into order of n square. Otherwise, this will be 10 to the power 6 square equal to 10 to the power 12. And you will be getting TLE error here. TLE. Okay. And that's when we have to be very careful about it when you are actually solving the problem on the online platform. So when you guys start doing it on the lead, when I talked about all of these things here, the order of it, this is very, very important. You should always go for optimizing it. Okay. What I will do is I will try to show you one more example and then that will make sense. Okay. So now tell me about it. I want to actually search some number. Okay. So I have, let's say, list. Another example I will tell. So just to show you, I have a list, maybe list here is there. And in this list, let us say I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. These are the number basically. And I have the target number that I want to find it. Okay. So this is the target number where I want to find 7. Tell me how many ways I can actually search this particular number. What do you guys think that? How can I search it? So I can actually iterate it over the list. Can I write something like this? Let us say a simple code. I'm just writing it. Let's say for element in list. Yes. And then what I will do, I will say if target equal to element, then I'm going to say return true. Yes. If not, then I will say return false. Agree? This is the most efficient way that I can do it. Actually writing a simple code that I can do, that I have to basically iterate over every number. Fine. But tell me, what is the time complexity that I have to actually go for here? What is the time complexity? We have to actually traverse for the entire list. And this entire list is what? N. N elements are there. Yes. So the time complexity for this is going to be order of N basically. Okay. Now I will tell you another way how we can actually solve this. So there is something called binary search, and binary search works on the sorted data. Do you think this is sorted data? It is actually in ascending order, right? So we can actually use the binary search concept here, and we can actually solve this using binary search. That's why I have written the code there as well. I will show you now, and I will execute and show you as well. Now, sometime what happens, let us say this search is not very optimum because you think about it, right? The products that we have, let's say Amazon and all, don't you think that the products will be huge in numbers, basically so many different numbers? In that case, the searching of using this order of n is very, very bad idea. Yeah, because I'm telling, the moment you are exceeding 10 to the power 9 input, like that many search, that many iteration, if you have to do, then you are gone. Actually, you cannot come out of it. So your processor is not going to support it, and that's where you're not going to do, right? That's where the some new technique come that is called binary search, and probably some of you might know already, computer science guys, right? Binary search. What binary search says, okay, I will be always discarding half of the search basically. Okay, half of the search. I will just show you actually how does it work. So let us say this is my example. Yes, 1, 2, 3, 4, 5, 8, 9. I'm going to search 7. In this case, actually, what I'm going to do, I'm going to search every single target. And in the worst case, maybe if my target is 9, then I have to go entire list. That's why worst time complexity, because they see Pigo notation actually tell you the worst time that it might take, the worst number of iteration. So worst case is this target can be 9 and I have to go, or maybe this target is, let's say, 12. In that case, I have to reach entire line and ultimately I will not find. In that case, also I'm traversing up to end of the list, right? Entire list I'm going to traverse now. In that case, this is also always order of n because that's the worst case. Now I'm going to actually optimize this because this is, let's say the interviewer might ask you, can you optimize this further? Because this is the very basic thing you can do. Anyone can do it basically, right? Then that's where this binary search will come into picture, and only you can do it when you know this, right? What I can do is, let me show you. Basically, let us say this is my list. And this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. They're the element, and maybe I have this time target is actually 9. Okay. Let us say I'm in previous case, I'm doing the linear search. So I'm actually checking everything from starting to end. And at the end, I'm finding, that's why order of n. Now in this case, let me actually show, this is the index, right? So this is 0 index, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Just pay attention, guys. It will be easier to understand. Now, what I'm going to do, I'm going to use the binary search. What binary search says, okay, I will, why not basically check something in the middle? because it is making sense. No, your data is in the ascending order, in the ordered way. So can we check in the middle? And based on that, I can decide whether I have to check in the left hand side or right hand side. Yes. So can I say that this is actually left, this is right? What I'm going to do, I'm going to find a mid of it. So I'll say m equal to L plus R, okay, and divide by 2. So what is the indexing? Zero index plus what is this? Eighth index. If I say indexing, so this will be coming 4. I will go and check at the fourth index. Okay, where is my fourth index? This is my fourth index, and this is going to be m actually for me. Okay, now can I check whether this target at index number 4 is less than target? I mean, the element at this index is, so what I can do, I can say list of, this is list, no, list of m. If my list of m equal to, just pay attention. Yes, if it is equal to target, what we are trying to do, list, this is m, no? So the number is actually 4, not 4, actually 5. The value is 5. Is 5 equal to 9? This condition is not satisfied basically. Then I will write another if else actually. So I will say if else, elif, no? We say elif, perfect. Here I'm going to check if my this number, whatever 5, is it less than target? Means target is bigger. If my target is bigger, pay attention guys. If equals, then fine, I will just return it. No, if it is equal, then I will simply do one thing. I will return mid m, yes, and then I say that, or maybe I can say found or something like that. Yes, but if it is not, then where should I search actually in this case? 9 is there, and it is saying that, okay, my this mid element, which is 5, pay attention here. If this number is less than target, which is 9, obviously it is, then where should I search actually? Should I search left or right? Left hand side always lesser number. No, so there is no point in searching this place. I have to search in this side only. Yes, correct. So in that case, can I increase my L to m minus m plus 1 basically? So my L will be, the search space will be actually, I'm discarding half part of it. My L is going to be sitting here actually in this case. Okay. Now I got a new search space. Now this one left and this one is right. Now can I say that if I add again to find a mid into this, can I say this is at 5 index plus 8 index by divide by 2. How much it is? 13 by 2 equal to 6. So where is my 6 index? My 6 index is this one. So this time my m is here. I will check whether my target, again, I will check whether my target, okay, whether element at this number, which is actually 7, is it less than or equal to target? Again, my target is bigger because target is 9. Yes. So where should I search? I should actually search on the right hand side. Again, what I will do, I will actually increase my left pointer will be going here, and left will be sitting at this place, left. Right, there is no change. Right will be still sitting here. Left, I'm going to say it because my search space now confined to this place. Now, can I do one thing? Can I actually say again, find a mid of it? So there are only 2 elements. I will say L plus R divide by 2. So L is actually 7 plus 8 by 2. 15 by 2 equal to 8. Perfect. Now this point of time, I'm saying, okay, at index number 8, is it equal to target or not? So in that case, I find, okay, index number 8, there is number 9. And if I say target also 9, in that case, I found it and I will return true, which means I said I found it. But tell me one thing, how many iteration I did, first of all? Did I do, how many elements are there, n number of iteration? No, I didn't do that. I did one iteration here, one iteration here, one iteration here, probably 3 iteration only. Yes. So can I just tell you that every time, just let me tell you the derivation, how it done. First iteration, it is little difficult guys, but pay attention, you will find. First iteration, I actually discarded half part of it. Yes. Every time I'm discarding half of it. Yes. So n by 2. Second iteration guys, second iteration, I'm again discarding half of it. So I'll say n by 2 and by 2. So n by 4. Correct. Again, third iteration, what I'm doing, I'm actually, whatever is this search space is this one. Again, I will be discarding by this one. So I will be saying it is actually n by 8. Can I say? But if I see it here, there is a pattern here. N by 2 power 1, n by 2, 2 to the power 2, and n by 2 to the power 3. Don't you see? N by 8. So can I say that every time there is some correlation here. And when I will be actually finding it, let's say I will be finding at the kth iteration. So when I say reach at the kth iteration, that time I find this place. But what will be the like time, like how much this will be at the kth time? So 2 to the power k. Yes, for third 2 to the power 3. So for kth, I will find. And the moment I find it, I will find a single element or I will not find. Doesn't matter actually. Find or not find, that's fine. So if I find it, I can just equate equal to 1 here. Okay. And then I will talk about it, why the time complexity is not order of n here. So if I say here n equal to 2k, can I say 2 to the power k? Actually, if I take both the side log of 2n, here also if I take log 2 to the power k, then simply guys, here will be still log n base 2 equal to k. Yes, you know the logarithmic method, right? So this will be cancelled out, only k will be there. So that means at the kth iteration, my time complexity is log of n base 2. Log of log of n base 2 is bigger or n is bigger? Let's do one thing. So that's what I told you here, no? So this is actually binary search. In binary search also, I was able to find it, no? So instead of doing order of n, I actually got the log of base 2n, this one basically. So this is always lesser. If you Google it and check what is the log of base 2n, actually, you will be able to find it. Okay, let me just show you. Here, if I say log of n base 2 calculator, yes, this one. Actually, I just want to go here. If I go to only calculator, maybe this will give me something. Okay. Chalo. So something is here actually. Okay. Let us see. So if I say log of 2n instead of n, it is x, right? So if I say 8 actually, now do you see only 3 is coming. 2 to the power 3 equal to 8 actually, right? So that's why. So think about it. There I was actually iterating for n number of times, like 8 times, let us say, to find one search. Here I'm actually iterating only 3 times because I'm actually able to use the binary search, and this is the efficient way of actually searching some element, and this will only work when you have your search space in the ascending order, like ordered basis, right? So this kind of pattern you have to look when you actually somebody is asking you in interview, can you write the optimized code? Because think about it, if I'm putting it here 1 2 3 4 5 6 7 8 9 10, think about it guys. Let's check it. This is the magic about it. This is 10 to the power 9. Is it 10 to the power 9? No, I think 8. I put a 9 also. Do you see that? This is like 1 million iteration if I have to run it. Probably I will not getting the output actually there. But here, if I use the binary search, I have to just run 29 times, which is actually nothing. It will be coming not even a microsecond actually, right? So this is the actually magic of using log of n base 2. Okay, that's why it is actually better than log of n, 100% better basically. So you should always look out for your answer within this. But there are many times where you will not be able to get your answer into this kind of complexity, time complexity. You have to actually go, for example, you want to get the factorial, you have to go for this necessarily. Yes. And for different kind of solution, you have to go for it. But in that case, your kind of the input will be very less. Your input will be higher, then you will never be able to get it basically. Yes. So you think like this. So this is basically order. Hopefully write some more code actually here, some pseudo code, and I will ask you guys, tell me actually what is the time complexity that you think about it. Okay. So that will actually solidify a little bit more concepts here. Let us write something here. For example, I'm writing something like for I in, let us say, range n here, and I will write it for j in range m. Perfect. Range m. And then I'm going to say print I and j, maybe something like this. Okay. Fine. Tell me what is the time complexity that you can find it here. What is the time complexity here? Is it m plus n? I will give you some options. Okay. M plus n, B, m into n. Okay. C, I will say order of n. All of them are order. Okay. Because big O notation I'm asking. C, order of m. What do you guys think that I want you guys A, B, C, D? What do you guys think? What if you are saying B? And you are right actually. You know why? Because see, this is basically what is happening. The internal loop will be finishing, right? For every single, like internal loop will be finishing first, and then you will be going internal. So it will be like, okay, how many times you are getting this one actually. For every times the internal loop will be printing for every single value. So it is going to do multiplication, cross multiplication basically. Same code. Let me write it actually here. So this is going to be this one. Let me write the second code actually. Yes, it is going to be fun actually. So I'll say again same thing. I'll say I in, let's say, range, and I will say here control G. Yes. Now here I'm going to say print I, and then again I'm going to write it here again, J in range M, print J. Okay. Now tell me the answer. Order of M into N, B, order of M plus N plus M, C, D, order of N, order of M. What do you guys think? Yes, so this is the right answer because we are not actually putting the nested for loop. That is the main thing, right? Here is the nested for loop. Acha, tell me one last question, okay? Last question, I want to write something like this. Let us say I have something like for I in range N, okay? And I'm going to say here for J in range M, perfect? And here I'm going to say print I, maybe J, that's fine. I don't want to print I. And then I'm saying break here, break, okay? What is the time complexity? How much it will take? A, B, C, and D. Okay, so this is order of M into N again, order of M plus N, order of M, order of N. What do you guys think? How much is the time complexity? Okay, let's see how the code will execute, right? First of all. See, what will happen? First time it will go inside, okay? It will actually do it for, let's say, 0. Fine. For the first time, it will go for 0 and it will come inside. It will again, J value will be 0 in this case because we are actually executing for 0 here. No, I value will be 0. So this is something like I will be 0. Okay. J will be again 0 here. The moment it comes and print 0 here, it is going to break, isn't it? It is going to break actually. So the moment it is going to break again, what do you guys think? That it is going to run for M times, or it is simply breaking and it is going to run again, take the I equal to 1 again, 1. It is not going to do, it is going to break it. It is not going to print J, like J will be only one time. It will not be 1, 2, 3, 4. How many times you are saying up to M time? No, this is not going to happen here. Okay, because we are putting a break. It will print only one and then it will break and it will go here. So in this case, if you say it, it is actually running only one time this particular instance. It is going to only run n number of times the outer loop, right? And that's why the time complexity will be order of n. Tell me one thing actually. I can write some code here, no? But let me just write in a bigger notation way actually. Okay? There are a couple of rules that I want to talk about it, and then I will go to space complexity. So some of the rules that we need to know, rules about bigger notation. Okay, guys. Chalo, amazing guys. Okay, let me do one thing. Let me actually let me write some rules, and those rules are very, very important rules for every asymptotic, like for the bigger notation. Yes. So first rule say, how do we calculate it, right? So these are basically calculation rule. So when you go for interview, they will be giving, you have to ask order of 1, order of n, order of log n base 2, n log base n base 2, or n square, n factorial, all those way only. Okay. But now maybe people might ask you something different way actually. Okay. Okay. Wait a second. Just to test your knowledge, whether you understand the rule also or not, right? So the first thing is how to calculate big O notation. Perfect. Big O notation, how to calculate. First of all, we have to say calculate the number of iteration based on input size. Okay. The rule number 1 says calculate the number of iterations, right? Iterations based on input size, है ना? Input size. That's why we said no. We can put n size, then it will be actually that one. Independent of internal factor. So can you say that iteration, whatever iteration we are saying, is it dependent on the programming language? Is it dependent on the temperature where you are coding, right? Your computer will perform irrespective of it, right? So that those are the parameters that we should not actually take care. So we should say that the input size, it should be independent of external factors. Okay, let me write it here. That's why we are considering the independent of external factor. I told you last time, like before we discussed it, what are the different factors it can have, like Mac or your coding, programming language, everything. Those are actually like the external factors, right? But here I'm talking about your Big O notation will actually calculate the time complexity, whatever time it is going to take and other things. It is based on the number of iteration. This is the important thing. Okay. Now, second rule, it says that we should actually take the higher order terms. Okay. When I say take the higher order terms, what it means basically, I will come back to you, and neglect the lower order terms. Okay. I will come back to it actually little later. The third rule says that ignore constant coefficient. Three things. Yeah. These two things I'm going to actually explain you guys. Okay. And I'm going to write a small code that will actually give you some. Now you have to tell me like what is the time complexity. I will ask you. Okay. Let me write this code. I will write a small function here. I'll say function and something like, can I say calculation, something like this? Yes, calculation. I'm going to do it here and I'm passing something like n here. Perfect. This is my input that I'm passing. Now inside this, I'm going to write some code here. Let us say I'm writing one for loop here. Okay. And then another for loop, I'm going to write it here as well. Okay. Two for loop here. And after that, I'm going to write another for loop here. And this is going to be, let's say, I will say here, let me write it a little better in range n here. Okay. In range n here as well. Okay. Something like this. And here I'm saying j in range 10 here. And again, inside this, I'm going to say write k in range n again. Perfect. And then I'm going to say here another for loop, which is, let's say, L in range n here. Perfect. Something print I'm going to do here. Okay. Here also I'm going to do print anyways. Now the last one, I'm going to say here something like maybe print end of program. Very high level pseudocode, guys. Okay. Now let us pay attention. How do we calculate the time complexity for this? Okay. So see here, what we are doing is we are basically writing two for loop. Yes. So this two can have the n square. Correct. For this two, what we are going to do? This is 10. So it is going to be 10n. Yes. For this 10 and then it's n. So 10n basically, right? 10 into n. This one is actually only n. Okay. And this one is going to be 1. Got it? Okay. Now, guys, if I say the total time complexity, can I say the total time complexity here? Let me write it here. Total time complexity, total. It is going to be n square plus 10n plus, 10n and then n maybe plus 1. So this is actually time complexity. But when interviewer will be asking you, can you tell me what is the time complexity? This is the total time complexity. But when you talk about the Big O notation, okay, Big O notation, I mean, this is the execution time that I can say execution cycle. This is how much you are getting. But actual time complexity, when you are talking about it, we have to actually fit into this particular rules. Okay. And in this rule, let me actually write it. So what I said, n square plus 10n, no? So 11n will be, right? 1, I will be adding it and 1, isn't it? This is how we can say, no? So this is coming to n square plus 10n, 11n plus 1, correct? This is the total time complexity. Now, let's fit into this one. So you cannot just tell interviewer that, hey, this is the time complexity that I'm going to do. No, this is wrong, basically. You have to actually make it simplified. Yes. So you have to say that, okay, the first rule is fine. Second rule is saying take the higher order term. So which one is the higher order term? This is the higher order term, bigger than this, obviously, especially for the big numbers. Let's say it is 10, right? Until 10, this one is bigger. Do you see? 11 into 10 if you do, and 10 square you do, this is better. So we actually, whenever we are talking about time complexity, we really think about the huge input, big input. So let's say this is 10,000, 20,000, whatever number is there. Then in that case, this is actually higher order term. So we have to actually take the higher order term. This is actually the one. Second rule says that ignore the constant coefficient. So this is actually constant coefficient. This does not take any time. This is order of 1 basically, right? So this I can do it, right? And this is also ignored because that's what I said, neglect the lower order. So this is the higher order already. If there is something NQ, then I will be increasing I will not consider n square as well, right? So total time complexity that you have to tell is order of n square. Okay, for this particular entire program, not this entire equation. Got it? So this is what we have to take care of it, how to calculate the big O notation. These 3 rules, it will make sense basically. Okay, everyone? Anyone have any question about it? Space complexity. It says that how much space, simply, how much space I am taking to calculate this program, actually to run this program, right? So it says that how much space, this is also called auxiliary space, For example, guys, let me write some code and you guys tell me basically how much this particular program is taking space basically. Okay. So let me write some code actually here. I will say here, let us say def, I will say something calc. Okay. This is okay. It is like too crazy. Let me write it a little bit better here. If I say def here, I'll say calculation function. I'm writing it here. Yes. And I'm actually passing it, let's say, n, some parameter. Yes. Some n number maybe. Yes. Now, if I say int, maybe I'm just writing some pseudocode, guys. Okay. Let us say this is integer type actually. Something like this I'm writing just to show you. In Python, we don't write it like this, but I just wanted to show you that this is integer data type and I'm going to store into a variable and this is going to be n. Okay. First. Second one is also another integer, which is y maybe, and this is x into x. Sorry, n into n. Perfect. Let's say n into n. Third one, let us say I'm going to say long z. Can I say x plus y? Something like this. And finally, I'm going to write something integer, a list, I would say, list of maybe n elements, maybe list of n elements. Okay, something like this. I'm going to just say list of 1, 2, 3, 4, 5 up to n. Okay, n here. Perfect. This is how I can do now. This is just a pseudo code, okay? Don't think that this will be working on Python, but just wanted to show you basically how it works. Now I'm talking about the space complexity, which means how much space I'm taking while calculating this program, because this is also important. Your CPU is like having the limited, your memory, not CPU, your memory, which is RAM, is also having the limited things, right? Maybe 8 GB or 10 GB, 16 GB. In the really huge program, it will be a problem basically. That's why it is important to calculate how much space I'm taking to running this program, right? So integer, how much it takes, guys? Anyone know how much space it takes? 4 bytes. Okay. This is also taking 4 bytes. Long takes, let's say 8 bytes. Okay. Now tell me one thing. These are basically, okay, let's say I'm not going to do it actually. Let's remove this. I don't want to take this. Only this function actually. So I'm talking about space complexity, how much space we are taking. Okay. Let's say this is my end of the program. Okay. Okay, leave it. Okay. Now tell me how much space we are taking actually total. 4 plus 4 plus 8. How much it is? 16 byte. Agree? 16 byte it is taking while executing this particular program. Can you tell me in any case, this particular space can be more? In any case, based on my input, because I'm passing, let's say here, some 10,000 or something like that. Can my space be more than 16 byte in any which case based on the input? No, right? It is not possible because I'm not actually doing anything with this. Actually, I'm not creating anything. I just have 3 different variables and I know each of these variables will be taking this much space and 16 is actually constant space. So wherever we have the constant space, I'm going to give you how much time complexity, guys? order of n, order of 1 actually. Okay. Now let me write the second program actually. Okay, same thing. I'm going to write the same program here. And so just give you some idea here. Def, let's say calculation 2. And here I'm going to say n input, I'm going to pass it. Okay, I'm going to write something, let's say int x equal to n, int y equal to x into x, whatever it is. Yes. And then at the end, I'm going to say, I'm going to create a list of it. And this list is going to be what? Going to be having 1, 2, 3, 4, 5, 6, 7, 8, 9, up to n. So this is list is going to be holding the n number of it. Yes. Can you tell me what is the space complexity for each of this now? So for this one, obviously we know 4 byte. This is 4 byte and there is no long, so it's fine. Now this will also take some byte, no? So this is actually integer, let's say, huh? This is also integer, so it is also going to be 4 byte. Here also we can actually calculate it 4 byte. I will tell you why we are not calculating. This is also 4 byte, so this will be essentially 4 byte. If I say it is going to be 20 byte total. Okay. Now think about it. Now this n is, let's say, such a huge number, and that in that case, this list is actually what? It is storing every integer basically, right? So this is also 4 byte. 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 Everything is 4 byte, and this is also 4 byte. So let's say n number are there. So how many actually byte we are going to consume? 4 into n byte. Agree or not? Because everything is integer only, no? All of this that we are storing in the list. That's why 4n. Got it? So total time complexity, sorry, space complexity, it is same way how we calculate the time complexity. So if I say total complexity will be 4 here, plus 4, plus 4, and plus 4n actually. Yes. So this will be how much? 12 plus 4n. So what I have to do, I have to actually ignore the constant coefficient, and I also have to ignore. Okay, so this is the constant coefficient, and this 4n, this is the constant also. This also I have to remove it. Lower order is this one, and this is constant coefficient, right? So this also I have to increase. So I can find actually order of n, which means this particular time space is actually can take up to n, means how much bigger number we are supplying it here, no? That much, that many byte it can take. So n byte it can take. Got it? So this is how actually you get the time space complexity basically, which means it will be taking so much of use. So always, we always have to see that lower the time complexity, better is from the space point of view. Got it? But okay, last thing you might ask actually, which one we should prefer? Okay, which one? Question is, which one we should prefer? Let us say we have the time complexity, TC, sorry, space complexity, I should say here. Why I'm saying time complexity here, guys? It should be space complexity actually. Okay, sorry about it. Space complexity, not time complexity. Okay. Here also, okay, order of, and this is fine. Yes, fine. And always, also one thing you should note, right? One thing you should note is this is actually given by the input from the user, no? So this, we should never actually conclude this also. Yes, this is actually, we should never conclude this because this is not our problem. This is user problem. So only thing is whatever it needing for computing your calculator, that is the only space complexity we should be considering. So in this case, this 4 byte that we are taking no input, this also is not ours. So it can be actually lesser, but it doesn't really matter. You know what? Because this is still a constant only, right? But you know that input and output, except that being a developer, I'm actually considering only the processing part, not the input and output. So your input and output, whatever is required, that is part of your program. So you should actually never consider that that is the user input. Okay. So only thing is you should be focusing whatever logic you are writing, how much space you are taking, that is the only space you are consuming, and that is the space complexity for you. Okay. Now, which one we should be better, time complexity or space complexity? What do you guys think? Which one we should be actually preferring in the today's world? I want TC. Give me the answer actually. TC or SC? A, B is SC, space complexity. Tell me A or B, not actually. Yes, actually TC. You know why? Because the time is money. Yes, time is money, and we should always go for, because the space is very cheap right now. Yes, you know, you can get 10 terabyte of memory into very, very less money, right? Obviously, like I'm talking about the RAM and everything, that is still very cheaper actually now. Yes, so we should always, there was a time when space was also very like very costly. We were storing the data in floppy and all those things. Those time gone actually now. That time data was not there huge, right? So that time the space was very scarce. Now Scarcity for the time is very important. Now, the thing is the time complexity, we should actually see how fast our program executes, right? And that's why we should prefer this. Wherever you find that the lesser time complexity is there, but you are actually consuming a lot of space, so you should always go for TC. Okay, in ideal case, if both are good, then it is better to actually achieve both of them. Otherwise, preference should always be on the TC. Okay, this is the last thing that I wanted to talk. Okay, because there is lot many things to do. I don't know how to explain everything, but whatever I wanted to talk about it, probably this is making sense to you guys, then it's good because within this limited time, 2 hours of time, this is what I wanted to conclude basically. Hopefully this given you some idea, and remaining, I will leave it you guys to actually explore it. Go and Google it, chat GPT if you want to do, whatever you want to do, just search about it and learn little bit more about it. And then you will be perfect. Okay? Okay guys, everyone. I want you guys to give me drop me a smile. Actually, the last one. I deserve a smile. 21 people are still there, which means I taught you guys good things, right? Today, at least. Okay. This is very, very complex topic. Trust me, right? And nobody want to talk about it. If you find very, very less videos, people will be talking about it. And that too, they will not talk about practically things, right? They will talk something like theoretical point of view. But just try to search something internet. You will find some good article basically, right? And if you can read about it, it's really good. Yes. Time complexity, space complexity, these are the two very important parameters when it goes to higher level, like let's say 10 years, 15 years. In those time, no, people will ask you because you are writing some automation code, they will ask you, okay, because in automation also you are actually sending huge amount of data. If your time complexity is not optimized, then your automation should will keep running for many days, right? That is very bad, right? So that is the reason it is very important. Yes, it is important for ETL automation. That's why I just finished, no? Because if you're writing in a very worst way, let's say n square or n cube way your code, then you're gone, right? Your automation will never finish it. If you are putting a huge amount of data, let's say 50,000, 20,000 n cube, it is barely like your program will like run it forever actually, right? Okay, so just be aware of it and try to actually learn more about it. But this will come once you are done with the programming, you know, little bit of programming, whatever we have learned, right, in our programming, that is good enough to actually apply all these concepts, little bit understanding, because nobody will ask a tester to actually go in such much deeper basically, right? So this, whatever we learned today, it's good enough. I'll send